Thanks everyone. Welcome to the session, and I'm uh, myself Amit Jain, and I'm a director from RTL Associate Design Group in Noida office. And today we are going to speak on NXP Auto, FreeRTOS, and in general RTOS, and from our global expert here. And so before starting, I just would like to give an overview of this session. So we started this almost 2 years ago, which is called NXP Campus Connect, and the motivation or the aim here is to get more better relationship between industry and academia, and make the students aware of what's going on in industry, and give some practical overview of the things which are happening. So in India, we are currently operating from 4 locations. So Noida, Bangalore, Pune, and Hyderabad, and all centers are center of excellence in one of the domain. And we have a strong global position, and uh, number one in automotive industry. And I would like to welcome and thank GLA University to host this session for today. So first of all, I would like to hand over this to the Dean HOD from Electronics Department, and Mr. Vinay Kumar Deolia. And so he's working as a professor and head of electronics and communication engineering, and he has completed his PhD from MNIT Allahabad, and he has more than 25 years of experience in this teaching domain, and he holds 2 patents and 58 international journals in various prestigious conferences. And he also look after for few PhD candidates under his valuable guidance. So I'm handing over to respected sir. So sir, please start from your side.
So thank you, Amit, for explain about the program. Good evening, everyone. Myself, Professor Vinay Kumar Deolia, Head Electronics and Communication and Electrical Engineering Department. On behalf of our GLA family, I would like to welcome all the respected and prestigious members and students present in this joint venture. We are very honored and thankful to NXP Semiconductor who gave us this opportunity to host this wonderful event. As a proud member of this GLA family, I would like to brief the remarkable achievements of GLA University. GLA accredited by NAC A+ grade for high standard infrastructure, learning resources, research, innovation, etc. GLA has got 12B status by UGC among top private universities in India. GLA received ARIA Band Excellent Award for blending innovation in learning and beyond classroom experiential activities by NIRF, Government of India. GLA awarded 11 to 50 band score by NIRF Innovation Ranking 2023. GLA received the title Best Private University in Uttar Pradesh in Engineering by Survey 2018. Now, as Head of the Department of Electronics and Communication Engineering, I would like to introduce all of you with our department. Our department offers 11 programs at UG, PG, and PhD level. Our department awarded till now 1 DSc degree and 21 PhD. 628 papers are published in journal for high repute in our department. 6 patents are granted and 55 patents are published by our faculty members in the department. Department is funded with 3.24 crore rupees project grant through various research project agencies. 90% plus above students are placed in reputed companies. Now, the department is moving with the objectives to provide quality education through periodically updated curriculum, effective teaching learning process, and best of breed laboratories facilities. We are also enhancing the research quality. Our research work is evaluated by experienced researchers in the field timely. To strengthen the education and research ecosystem, we collaborate with academia, research institutes, and industries across the globe. We are also imbibing the spirit of entrepreneurship and innovation in our students. In our department, we are taking very good initiatives for advanced learning of students like real-time industry-oriented projects, MOOC, oblique advanced courses, classes for competitive exams, internships, students participates and organizing intercollegiate technical competitions, symposium and conferences. Apart from this, we are having academic and industry collaborations, MOUs with Texas Instruments Innovation Center, Siri Pilani Semiconductor Laboratory Chandigarh, and many more. Under these collaborations, we are strengthening the technical skills of our students by providing industrial training come job oriented programs to take advantage of social, environmental, and economic opportunities. Now, I am pleased to inform you that recently we opened three new programs in the department that BTech Electronics and Communication, specialization in VLSI, BTech Electronics and Communication, minor in Computer Science, and another third one is BTech Electrical Engineering, specialization in electric vehicle. So I am requesting to Dr. Vinay Kumar Tomarji, please come and explore maximum possibilities of these programs. Thank you. Thank you one and all. Thank you.
Thank you very much, Achodi sir. To demonstrate the accomplishment of GLA University and EC department, I am Professor Vinay Tomar. So recently we have introduced a new course that is BTech EC with specialization in VLSI. In this emerging domain, to establish India as a key partner in global semiconductor supply chain, Government of India has taken some good initiatives like Union Cabinet has allocated an amount of 76,000 crore for supporting the development of semiconductor and display manufacturing ecosystem, and in support of this plan, Government of India has launched two schemes. One is SPEC, another is PLI. By DLI scheme, Government of India target to nurture at least 20 domestic companies involved in the semiconductor design. Karnataka signed a MOU with Israel-based ISMC Analog Fabrication Private Limited for setting up over the next 7 years with employment potential of 1,500 people. Therefore, in view of these emerging opportunities, our aim is to provide our student a fundamental engineering view of digital and analog IC design, which are potentially used in chip design and manufacturing industries. Well-designed VLSI curriculum, which is correlated by the industry expert, applied as a board of study member in collaboration with GLA University. Our industry partner and their senior staff are also invited to teach applied modules in the classroom. World-class laboratory with Center of Excellence in VLSI Design and state-of-the-art simulator like Cadence Virtuoso, Advanced Design System, Tenor Tool, Vivado Xilinx Design Suite, and FPGA board. Our students are getting expertise in design of static random access memory cell topologies for IoT-based application. Radiation hardened SRAM cell for space application. So, and our students are able to join various job perspectives like analog design engineer, digital design engineer, layout design engineer, and many more. So with these prospective opportunities in the field of VLSI, I would like to end my speech here with the expectation that GLA and NXP Semiconductor will have fruitful collaboration. Thank you, Team NXP, once again for giving us this wonderful opportunity. Now I would like to hand over the mic to NXP team to speak more regarding this joint venture. Thank you, sir. Thank you, Abhi, sir.
Yeah, thank you, sir. So I think now we have, I think today's topic is very important, and we have our expert from Vietnam team. So I would like to hand over now the session to Min, and that so please start, Min, first, and after that that you can take over. Thank you.
Yeah, sure.
Let me start my presentation.
Yeah, we can see the slides.
Does everyone see my slide?
Yes, Min, it's visible.
Hello, everyone. Today I'm going to present about NXP FreeRTOS project. Um, Before start, I would like to introduce myself. I'm Minh. I have been working for FreeRTOS about 2 years at FPT Software. I am a senior software developer. I am responsible as technical leader in NXP FreeRTOS project. Uh, I'm interested in embedded industry, especially operating system domain. Next. Before I talk about main content, the agenda will help us understand the key topics we will explore in detail. There are 6 topics. The first is overview FreeRTOS, about FreeRTOS. The second is NXP FreeRTOS offering. After that, we learn about how to install and how to use NXP FreeRTOS. Then talk about same case study 1 with S32DS and case study 2 is a standalone sample. Final part is what we are doing. Next, about overview FreeRTOS. FreeRTOS on real-time operating system is lightweight and efficient embedded operating system. It is developed to provide a reliable solution for application that demand high time accuracy, such as in embedded system requiring reliability. Some key feature and advantage of FreeRTOS like first, lightweight and flexible. FreeRTOS is designed to have a small footprint, about 9 KB, and is compatible with various processor types. Another advantage, efficient task management, allowing the division of application into small tasks that can be processed concurrently. And FreeRTOS support many architecture, include Core ARM and RISC-V. Real-time scheduling provide scheduling mechanism and priority to ensure handling event in real time. FreeRTOS play a crucial role in building embedded system. assisting engineers and developers in achieving stability and high precision. When deploying their applications, FreeRTOS can be used for any purpose under its MIT license. The next slide. Uh, Go to architecture of FreeRTOS. The FreeRTOS work include FreeRTOS configuration, so code for task, list, queue, timer, and portable. About FreeRTOS configuration is where you can customize the crucial setting of your real-time system. Um, this configuration file contain defined statements and configuration options depending on the specific requirements of application and embedded system. About portable in the context of FreeRTOS, the term portable refer to ability ability to easily as task context switching, real-time scaling, and interacting with hardware. The port.c and port.s file where significant changes and command optimization are made to ensure compatibility and performance on a specific platform. And there is a structure of a standalone application. Next slide is NXP FreeRTOS offering distributed freely under MIT open source license. FreeRTOS is an open source real-time operating system. MIT license distributed freely under the permits MIT open source license, allowing flexibility and widespread use, uh, and support more than 40 MCU architecture, uh, include ARM, Cortex, RISC-V, and more. NXP FreeRTOS integration with S32DS configuration tools and really via NXP Flexera offer path to production with Zephyr OS in the future. NXP FreeRTOS is supporting NPIs. Example S32M2XX, S32K1XX, S32K3XX, S32Z2Z3, S32Z2E2, along with the core architecture. Cortex M0 plus M4F, Cortex M7, Cortex R52, and M33. NXP FreeRTOS is using ZCC compiler and run with debug J32 and NXP S32 debug probe. Next, FreeRTOS really include update size, FreeRTOS kernel sample application, quality document, and quality level is class O. We can find NXP FreeRTOS on the NXP Flexera website. The image above is an example of ORTM S32ZE released at the FreeRTOS project just released in October. In here. So how to install FreeRTOS package? To install, we need to prepare S32DS tool and setting it. We download FreeRTOS and SPI DS, S32DS and RTD package on NXP Flexera. The package information into release notes of FreeRTOS. After fully preparing the environment and S32DS, we proceed to add and install the package. The steps are shown in the figure. After install complete, so how to use the NXP FreeRTOS. In the topic, we will learn how to add a new project and how to create and run an existing example. In the slide is a step to perform. After update code to add FreeRTOS to the new project, we will see the source code of the FreeRTOS and FreeRTOS configuration. Main.c is empty because of this is the new project. So user need to create main.c depending on their purpose. Create an example is almost like adding a new project. The only difference is that we just need to update code and will without adding FreeRTOS and creating the main.c. To run example, let's go to the next slide. About case study 1, I want to talk about S32DS project example. The FreeRTOS example create and scheduler to tasks to toggle. On this slide, I will walk through the process of creating and running an example on S30 example on the S32Z2 platform. Yeah. After creating the example, user can process to build the project. The output state is located in the debug RAM. Step 1, create the example. Begin by creating the example on the S32Z2 platform. I mentioned it in the slide above. Step 2, build the project. Once the example is created, the next step is to build the project. This process compiles the code, check for errors, and prepares the executable files. And step 3 is output. we are running with J2 after a successful build. The output is generated in the debug RAM. To run example, we open J32 tool and start open file.cmm, file run.cmm. Next. Because the S32DS example project is dependent the S32DS and RTD project. So the NXP FreeRTOS project provide standalone application. Understandably, it is like a demo. In the demo, we schedule tasks. We use a semaphore and interrupt of PIT, STM, and IRQ handler. The demo includes FreeRTOS code from kernel, FreeRTOS configuration stub code, linker file, and vector table. Along with that, demo you make file with the sequence environment and GCC compiler to build. Demo is using file.cmm to run Lauterbach J32. In the slide is step to build and run the standalone. User can view detail in README. To sum up, so what we are doing, FreeRTOS, and we provide the bot support package for S32 device, include update size package, demo application package. We test port kernel FreeRTOS using tooling. Use tooling as Lauterbach J32, NXP S32 debug probe. We internal CI/CD for automate testing and release package preparation. Below my present. Thanks for your listening. Next, I would like to invite that sharing about Zephyr project.
Okay, firstly, I'm very honored to be here and talking about the project that I'm working on. I'm working on NXP Auto Zephyr project. So before we start, I would like to introduce about myself. My name is Dat. I live in Hanoi, Vietnam, and my major is about electrical engineering. I worked in NXP Zephyr project is about 3 years, right after I graduated. Today I'm a main developer of the project and also a collaborator for Auto Zephyr team in Zephyr community. About the agenda in this presentation, I have four main topics. The first one is about the overview about the Zephyr RTOS project. The second part is about NXP Auto Zephyr offering. The third part is the work that we are working and the last part is Q&A. So we go to the first part. An overview about Zephyr project. Zephyr project is a member of the Linux Foundation subsystem. Zephyr project offer an real-time OS, uh, open source real-time OS. Zephyr real-time OS, real-time operating system, is delivered over Apache 2.0 license, and the project is being contributed by various vendors, and NXP is a platinum member of Zephyr project. Zephyr project support various SOCs and various boards. Right now, there are more than 500 boards are being supported by Zephyr. A quick overview about the properties of Zephyr. The first one is small. Zephyr can be built and can be run on the target device that has minimal limited about the memory. For example, it can run on the devices that has only 8 kilobytes of flash or 5 kilobytes of RAM. The second is about scalable. Scalable means with Zephyr projects, with Zephyr OS, application can be minimal, such as connect with the sensor to read the information about the sensor or control the GPIO pins to more complicated applications such as the multi-cores. The flexible and the secure. Right now, Zephyr are supporting various core architecture. Some of them are ARM, of course, the RISC-V, the Intel. The next slide, I will introduce about an overview about the feature that is provided by Zephyr OS. As mentioned in its previous slide, Zephyr is built with a lightweight OS. And as you see in the right part of the slide, we see there are a few layer. There are a few layer for the Zephyr OS. The bottom from the bottom to the top, we see the HAN, which is stand for hardware abstraction layer, the kernel, the OS services, the application services, and also the third-party libraries. Zephyr OS is not only provides the kernel, which is similar like the rest of real-time OS with the minimum with the features like the semaphore, the mood text, the memory protection mechanisms, and so on. The kernels will allow the application to run on the real-time system. Besides the kernel, Zephyr also offer device driver and the OS services, which allow the application can be written in portable way. For example, besides the kernel, Zephyr is very strong in connectivity. For example, the following technology is supported by Zephyr. Is about Bluetooth, the Wi-Fi, the Ethernet, the CAN bus, and so on and so on. Right now in my project, we are also enable the Ethernet and the CAN bus on Zephyr OS. The important part is about the developer friendly. Zephyr provides a lot of device driver, the subsystem to 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 have uh, the developer to write the application easily. One of my list here is about the logging, the tracing, and the debugging. Logging and tracing is something like uh, you somehow to save, somehow to print the information where the application is running into the output. The output can be the serial output or some other thing else. You can store the output in the RAM, in the flash, or print directly in the console. So that could help easier for debugging when developer implements the application. Another thing I would like to mention is about the Zephyr has a built-in cells. It is like a terminal, like you can input the command from the keyboard, and then Zephyr app will execute the implementation. For example, when you connect the board with the host machine, such as over the UART interface, and then with the supporting from the Zephyr cells, you can send the ping command, the ping command to the host, and get the reply from the host machine. Right now, Zephyr is supported and can be built in most of popular operating system like Windows, Linux, and the Mac OS. The next part is about the NXP Auto Zephyr, the project that I'm working on. The auto means automotive. Uh, what we are doing is enable Zephyr projects to run on NXP S32 automotive processors. In NXP, there are many product lines that are also supporting Zephyr, and we belong to the automotive product line. So that's why we call NXP Auto Zephyr. In our project, we use a software package called NXP Real-Time Driver or RTD as a hardware abstraction layer to configuring the device driver. NXP Real-Time Drivers is it developed it developed with both AutoZar and non-AutoZar layer. In our project, we only use the non-AutoZar layer. One of the powerful of the NXP real-time drivers is that it is written with the ISO 26262 compliance. That is a standard is um, applied in the automotive market. About releases, the project we have right now we have two type of release. First is downstream, and the second is upstream. Downstream means as we will deliver our software package in an internal web from NXP, which is called Flexera, which is similar like what Ming from FreeRTOS team was presented will present. As a customer, may want to contact you may need to contact with the NXP site to get permissions to download the software packages from the internal Flexera. The second release we are delivering right now is about the upstream release. Upstream release means we contribute all software directly into the GitHub. By that, a customer can fetch clone source code directly from the GitHub and and run on their devices. There are a few different between the upstream and the downstream releases. Those are actually two different types of software package and different types of code base. In general, in our projects right now, we support only GCC. From the downstream is a GC is customized by NXP, and in upstream is a GGC is customized by Zephyr community. Another thing is different is that the software is used as a hardware abstraction layer. In downstream, as I mentioned, the RTD, the NXP real-time driver will be used. But for the upstream, besides the RTD, we also use another SDK provided by another product lines from NXP, which is called MCUX Special SDK, which maybe one of you maybe know about it. And why in the upstream we use both RTD and the MCUX SDK as the um, hardware abstraction layer. The hardware abstraction layer is owned by its vendors. For example, NXP has its own HAN repository in the GitHub. We reuse the MCUX SDK because NXP Auto Zephyr is not the first team in NXP contributes to Zephyr community. Besides, there are another product lines which is called edge processing, and they are contributing various device in a community such as the Kinetics, the LPC Expressos, or the Dynamic Real Time. They contributed to community before us. So there are some, the IP, some peripherals are shared between their MCU and the NXP S32 MCUs. So we will not reinvent the wheel by reuse their drivers and reuse their SDK. That would help us to reduce the efforts to get a feature is available in community. I will show a little bit more detail about the downstream release. The downstream release is delivered internal over the Flexera, and then uh, is supporting only NXP GCC um, and as put in the slide, there are three main devices are being supported by us for the downstream release. Unfortunately, those are not targets for mass market. The R41 and the STX is for the radar application. The ZE is target for vehicle networks solution. And about the upstream release, right now in the upstream release, we support two type of device. The first is a H2ZE as request from the SOFE, which is come from the ARM. They are enable some network connectivity in Zephyr. And the second is a new one. We got the request to publish the support for S32K3 for upstream for mobile robot mobile robotics team from the beginning of this year. The S32K3 is a mass market, so I think you can easier to buy some of S32K3 boards and then download the source code from GitHub and tries to build our own application. And for the upstream, there could be more and more requests come to us, and we we are very interesting to have this chance to be able to contribute uh, to be able to contribution to Zephyr community. The next slide is a brief about the device driver that we are supporting. Uh, in the left picture, there is the hierarchy of the Zephyr project. Basically, we the main the main the main work that we are doing is writing the device driver. As you see, there is I2C, the SPI, the UART, the GPU, and enable them to NXP S32 processors. In the table in the right slide, uh, is a list of the peripherals, the the SIM driver in Zephyr that we are supporting. Um, uh, be aware that I just list here all the peripherals that we are supporting. Some of them may not available in upstream or available in the downstream because depends on the request from the customer. We will implement the SIM driver their based on their perspective. In general, we now are enabling most of basic peripherals to be used by the applications. Some of them are very familiar, such as GPU, the I2C, the pin control, the PWM for motor control, and the networking. For the networking, right now we are offering the Ethernet and the CAN bus. The next part is more deeply in what we do. As mentioned in the previous slides, we what we are working is enable Zephyr projects on any NXP S32 device, which also calls as the board support package, the BSP. What we do is the writing the SIM drivers, which is an adaptation from the Zephyr APIs to the RTD Laravel APIs for the downstream and for the upstream. Beside RTD, also the user MSUX SDK. Each SIM driver depends on the complicated of the SIM driver. For example, with the GPIO, which is similar, the size, the line of codes for the SIM driver is just about a few, something like 1 or 200 lines of code. But for the more complicated peripherals, such as the CAN or the Ethernet, the line of code may be around more than 2,000. Besides the SIM drivers, we also enable we also involve on some architecture codes because in communities in GitHubs, there are there may be some core architecture are not supported or are not fully supported by community. So we need to add support for this kind of architecture by our own. For example, with the ARM Cortex R52, we are in community. They are supporting the ARM32 instruction set, But in our team, by request from the customer, by request from higher management, we need to able to run the Zephyr on Cortex R52 on the thumb instruction architecture. So we need to um, implement this new feature um, by our own. And then after that, we depends on the request. We can upstream that support. We can decide to upstream that support or not. Right now, we are opening the pull request for support thumb mode in the GitHub community. Besides the C source code, we also supporting uh, for the debugger for download the binary into the memory or to debug sections. Zephyr project offer a West tool, which is very powerful tool. By using West, you can use it for clone source code, for build, for deploy the binary into the target device. Right now, we support West Runner for three type debugger. The first one is the Lauterbach Choice 32. The second one is NXP 82 debug prop, which is developed by NXP. And the third one is about the J-Link, which is used popular in commercial. Besides the feature, besides the tools, we also actually Zephyr projects is offering an test framework which is called Twister that can help the vendors to automate testing on their devices. Right now, we are also leverage the powerful from that tool to uh, to write the test, apply the framework to write the test and to run the test automatically. An interesting part I want to mention that we have our own bots. Um, we add some new feature um, from our side into the test framework from community, because there are some tests which require the input from the keyboards, such as if you want to test the Ethernet, you just basically send the ping command to send the ping command and wait the feedback from the host. So in normally is when it need to be tested manually by connect the bots to the host, open the terminal and it puts the ping command from the keyboards, and then the Zephyr application will run, or the test will run. It works. That requires a manual step that we definitely want to avoid. So we have adding on source code, actually the Python source, to uh, to automate such kind of test, um, which is some kind of interactive test that it requires input from the keyboard or something like that. In general, we just instead of input from the keyboard, we just send the command. We just define all of the commands need to be run by the test into something like an YARN file, and then the framework will read the YARN file and define the command step by step, so that after we get the command, we use the serial library, such as the one provided by the Python, to to send the command to the bot over UART, and then the bot will execute the interactive test automatically. And right now we are having 100% of tests automatically. that would help us a lot to to detect the issue either during the development or in the release. Yeah, so far is what we want to say about the NXP Auto Zephyr project, the project that I'm working on, and it's one of my favorite projects. In the last slide, I put some link into the information that I presented here, and if interested, you can click to it and find more about the Zephyr project itself and about all project. So that's all what I want to say in my presentation. Thanks for listening.